Okay, so we're looking to find an equation for x in terms of t. So we've got to solve this second order differential equation. We'll start with the complementary function. So we're going to do the auxiliary equation. So we've got m squared plus 6m plus 9 equals 0. So we've got m plus 3 squared equals 0. M equals minus 3. So we've got x equals at plus b e to the minus 3t. That's the solution to the complementary function. Now we've got to find a particular solution. Because we've already got an e to the minus 3t, and we've got a t lots of e to the minus 3t, we're going to have to try let x equal ct squared e to the minus 3t. This is why you always do the auxiliary equation first, find the solution to complementary function before you look for the particular solution. So dx by dt equals minus 3 ct squared, lots of e to the minus 3t. Just using the product rule, differential this times this, take plus differential that times that. And x double dot, or 2x by dt squared. Differential this times that. So it's 2c minus 6ct. And then we're going to do this will be times e to the minus 3t, and then times differential this, which is again it's a minus 3, so it's minus 6tc and minus 3 plus 9ct squared, all times e to the minus 3t. Okay. Now we know that this must satisfy this. So what have we got? That implies, right, 2c minus 6ct minus 6tc plus 9ct squared plus 6 lots of 2tc minus 3ct squared plus 9ct squared must equal 2. Okay. Now if we compare terms, we compare the t squared term on both sides. We get 9c, take away 18c, plus 9c equals 0. Okay, that's fine. Doesn't help us at all, but okay. Compare the t terms. We get 0 equals 0. Again, not a great deal of use. If we'd have cancelled that, we'd have noticed this. And the constant term, so we're just left with 2c on the left. If I simplify that, I'll just get 2c, but I haven't bothered. 2c equals 2, so therefore we've got c equals 1. So particular solution is x equals t squared e to the minus 3t. So therefore the general solution is x equals the solution we had earlier to the complementary function plus the particular solution Okay, next part. We're told that the velocity is 1 when it's moved a position of, okay, so x from t is 0, x equals 20. Okay, so initially it's moved 20 centimeters away. So that tells me 20 equals b 20 equals b. Okay. X dot, differential of x is, okay, so again we have all e to the minus 3t's throughout, so I'll leave that at the end. So differential of this times this, which is just a, plus this times differential of this, which is minus 3at minus 3b, plus differential of this times this, which is plus 2t, plus the differential of this times this, which is minus 3t squared. And we're told that, what we're told. Okay, so we're also told that it's given a velocity of 1 meter per second. So we know that x dot is 100 because we're measuring in centimeters, not meters. We're a little bit careful. When t is 0. So this time we get 100 equals a 0 minus 3b, and the rest are 1s, zeros and a 1 at the end. I already know b is 20, so that implies a equals 160. Okay, so now I've got, do I need this? Do I need something? Alright, so I've got x equals 160t plus 20 plus t squared e to the minus 3t, this particular scenario. And then we've got find the time. So maximum displacement is when the velocity is 0, so x dash, differentiate this times this, differential this times this. I could just use this one up here for x dash, but I'll do it again. 160 plus 2t, and this differentiated, minus 480t minus 60 minus 3t squared e to the minus 3t. So, move up again. So x dash equals minus 3t squared minus 478t plus 100 e to the minus 3t. So x dash equals 0 implies, I'm going to solve this quadratic, t equals minus 159, which is not valid, or 0.2089. So x, the maximum value of x is when I plug 0. This in is 160.2089 plus 20 plus, I could probably skip writing this out, e to the minus 3 of those okay, and that comes out to be 28.6 centimeters. Now in the test, the time taken for the mass to return to its equilibrium was measured at 2.86 seconds. So if we plug in x, t equals 0.86. We plug that in to find x, and we get 0.0912. Okay, which is in centimeters. So it's less than 1 millimeter away from 0. So the model is supported. By this, bottom again, by this measurement.